So in the next problem, the question is stating two particles each having a mass m are placed at a separation d in a uniform magnetic field B as shown in the given figure. They have opposite charges of equal magnitude q. At time t equal to 0, the particles are projected towards each other with a speed v. Suppose the Coulomb force between the charges is switched off. So this is an interesting point which must be kept in mind, that the Coulomb force between the charges is switched off. Find the maximum value Vm of the projection speed so that the two particles do not collide. In the next part, the question is stating what should be the minimum and maximum separation between the particle if the above calculated velocity is reduced to half. And then the next one is at what instant will the collision occur between the particle if v is equal to twice of vm. And then the last part, the problem is saying suppose v is equal to twice of vm and the collision between the particles is completely inelastic, so we have to describe the motion after the collision. So it is a very interesting problem that we are going to deal with. So the first few things which must be kept in mind, that the two particles are having the same speed and the magnitude of charge is same, but the direction is different. So now over here one thing is for sure true, that if we see the direction of the positive charge, so the positive charge will move in the upward direction because of the velocity and the direction of magnetic field which we have. That is, the positive charge is going to move in a path like this, in the upward path. And if I talk about the negatively charged particle which is approaching from the other direction in the same magnetic field, so this negatively charged particle is going to move in this direction. And this is the reason that there is a tendency for them to collide. So the first thing that we wish to know is this part, that what is going to be the direction of the motion of each charged particle. So now the first part is asking find the maximum value Vm of the projection speed so that the two particles do not collide. So since as I mentioned over here, that the value of charge, velocity and the value of masses is same for both the charged particle, so I can say that they both will move in the same radius r equals mv by qb, and their motion is governed by the direction which we have already determined. So in order to prevent the collision, so I am drawing one more diagram. So in order to prevent the collision, this is the possibility which we can think of, that as the charged particle is moving, so it will move out like this, the positive charged particle, and the negatively charged particle which will start from the other end will move out like this, such that they just brushes against each other. And we are saying that this separation is given to us as d. So the value of radius in which this charged particle is moving is d by 2, and for the other one is also d by 2. That is, we can say that the value of r is equal to d by 2 and can be equated to mv by qb. So if we equate this to mv by qb, so we can calculate from here the required velocity, which can be written as qbd by 2m. So this is the answer to first part, where the problem is asking us to calculate the maximum value Vm of the projection speed so that the two particles do not collide. Now in the next part, the question is saying what would be the minimum and maximum separation between the particles if the speed is reduced to half. So if we reduce the speed to half, so the value of radius which we saw over here was d by 2, and we have seen that m by qb remains the same. So if I reduce the velocity to half the value, that is vm by 2, so this is also going to reduce by 2, that is it is going to move in the radius which is equal to d by 4. So for the b part, this is the calculation which we have done, that if we reduce the velocity to v by 2, so the radius is going to become d by 4, or you can also cross check from this result that if we use the velocity equation v by 2, then we can calculate radius for b part over here again using the velocity v by 2. So the value of radius can be calculated as mu radius, which is equal to m. So velocity is half of the current value, that is 4m by qb. So from here we obtain the same result, that is d by 4. So now if the charged particle is moving in the radius of d by 4, so if we consider another diagram, so I am saying that the charged particle is moving in a radius of d by 4, and this was the starting point, and the negatively charged particle is moving in a radius of d by 4, and this was the starting point. So this is the point of minimum separation. So this is going to be the point of minimum separation, d minimum, and this is going to be the point of maximum separation, that is I am writing with capital D, d maximum. Now the problem is telling us that the initial separation between them is small d, and the radius in which it is moving is equal to d by 4. So we are taking this distance as d by 4 and this distance as d by 4, and hence I can say that the minimum distance between them will be this parameter, that is equal to x. So from here I can write that d by 4 plus x plus d by 4 must be equated to d, that is this is equal to d by 2, so x is equal to d by 2. So d minimum, or the minimum separation between them, will be d by 2. And if I calculate the maximum separation, so we already know the center to center distance, which is equal to d. We only need to add these parameter, that is d by 4 on both sides. So we get the maximum distance as small d plus twice of d by 4. So from here we obtain the value equal to 3d by 2. So for this problem we have solved the b part as well. Now if we come to the last part, at what instant will a collision occur when the particle speed is equal to twice Vm? So if the particle speed is equal to twice Vm, so what is to be done is that we are trying to calculate the value of time when the collision will take place. So in order to collision to take place, both the particles must cover equal distances. So if both the particles are covering equal distance from here, so we are saying that the velocity is twice of Vm. So if we approach this problem like this, so if the problem, this was B part, now we are dealing with C part. We are saying that the velocity is equal to twice of Vm. So Vm is calculated by us as qbd by 2m. So if I put the value over here, so we get twice of qbd by 2m, that is the expression will reduce to qbd by m. So this is the value of velocity which we have, that is twice the value of velocity. So if we consider that the collision take place for this will be r is equal to mv by qb. So this is the next radius which we are calculating. So I am calling it as r3, that is m by qb into qbd by m. That is they are moving in a radius equal to d. So now what will happen, as the charged particle move, it will move something like this. This is the trajectory of the positive charge particle plus q, which is moving with twice Vm, and the other one, which is the minus q and is also moving with twice Vm, will follow a trajectory like this and it will collide somewhere here. So the collision will happen at this point where the initial separation between them was equal to d. So each of them is a part of circle whose radius is equal to d, and they are colliding at the midpoint, that is d by 2. That is d by 2. So they are colliding at d by 2 mark. So if I draw this in the form of a circle, So it will be better for us to understand that we are considering that the particle was moving like this in a circle with a radius equal to d, and the collision take place when it moved this distance which is equal to d by 2. So this distance is equal to d by 2 which we have. So if we calculate the angle which it have moved, so this is the angle which we are looking for. So if we calculate this angle, we can calculate using sine, that is sine theta is equal to d by 2d. So the value is equal to half, that is it have moved an angle of 30 degree. So we can say that it have moved an angle of 30 degree or pi by 6. So the question is asking us to calculate the time taken for the collision to take place. Let us come back to the question. So the question is at what instant will the collision occur? So since we know that the total time of the circular path is 2 pi m by qb, so in order to move this distance pi by 6, so we can say that for moving 2 pi, the distance, the time taken is 2 pi m by qb. So in order to move pi by 6, the time is going to be pi by 6 m by qb. So this is the time after which the collision will take place, that is pi by 6 m by qb. Now let us deal with the fourth part of this problem. So if we deal with the fourth part of this problem, the problem is stating suppose V is equal to twice Vm and the collision between the particle is completely inelastic. Describe the motion after the collision. So this one is a much simpler problem in comparison to the above three problems. So the problem is saying that the collision which takes place over here is completely inelastic. So even if the collision is completely inelastic, we say that the momentum along x-axis will be conserved. So if the momentum is conserved along x-axis, I say that initially the particle was having the same component of velocity along the x-axis, and hence the velocity component along the x-axis will cancel each other out, and the particle will move in the straight line along the y-axis. So if we describe the motion, so the motion of the particle will be that the particle will stick together and the combined mass will move with a common speed along the straight line, which can be drawn upward in the plane of the figure like this from the point of collision.